was the power of the machine doing the work?
Okay, so what is the 2,500 joules? What's that? That's the work. 100 meters?
Distance.
10 seconds?
Time.
Time. So we need to figure out what is the force needed to do the work. Then we need to find the power. So let's figure this out. Let's figure out what we have here. We'll go 2,500, 100, 10 seconds. Let's list everything we know. 2,500. 110. $100 what? Was it meters? Yes. 100 meters, 10 seconds. Okay. So, it wasn't 2,500 newtons, it was 2,500 joules. So we were given the work, we were given the distance, we were given the time, and we were asked to find the force needed and the power of the machine. Okay? So we're looking for force and we're looking for power. Okay, well, here's the thing. If I have work and distance, I can use my work equation. Work equals force times distance. Help me solve for work, right? That's one way. And then I'm going to need my power equation. Power equals work divided by time. Split your solutions box in half, everybody. For the first part, work is equal to force times distance. How do we solve for force?
You divide by distance.
So let's divide by distance and rewrite. Force is equal to work divided by distance. Work was the 2,500 joules divided by 100 meters. This is pretty easy because you can see a couple factors of 10 are going to cancel. We don't need a calculator for this one. We're looking at 25 newtons of force. Okay, and then finally, to find the power, I'm just going to use the equation work divided by time. So we got 2,500 joules of work. That's why it's so important to list your stuff over here, then you know exactly where to plug it in. And then the time was 10 seconds. Again, one factor of 10 cancels, and we're looking at a power of 250. I need a unit.
Watts.
Watts. Okay, may I get a reader on number 8, please?
A machine uses a force of 200 newtons to do 20,000 joules of work in 20 seconds. Find the distance the object moved and the power of the machine.
Okay, so this time we're given force, work, time. We're looking for distance. Okay, so we're given 200 newtons, 20,000 joules, 20 seconds. Let's copy that down. 200, 20,000, 20. So the first one was 200 what? It was newtons, right?
200 newtons.
Of force, 20,000 joules of work, and 20
Seconds.
seconds of time. And you were looking for the distance. Look at what you have here, guys. You've got the force, the work, and the time, and you're looking for distance. We could use our work equation. Work equals force times distance. And solve for distance. How do you solve for distance?
Divide by distance.
Whoops. Divide by the force. Distance is work, 20,000
Oh, you put
joules of work.
A.
Sorry, meant to write D. 20,000 joules of work divided by 200 newtons of force. You can see a couple factors of zeros cancel, and 200 over 2 is
100.
100 meters.
Oh, yeah.
So it turns out we didn't even need the time, did we? No. I just want to do one double check on the question number 8 just to make sure there wasn't anything else we were supposed to find. Oh, yeah. So we had to find the distance and the power. So we do need the time for the power calculation. I wasn't sure if it was a two-part question. So we're looking for distance and we're looking for power. So I'm going to squeeze that in there, wherever you can kind of squeeze that in there. Power is equal to work over time. So let's go 20,000 joules of work divided by 20 seconds. Again, one factor of 0 cancels, one factor of 10. Power is 2,000 over 2. 1,000 watts. And lastly, can I get a reader, please, on number 9? Please, thank you.
A machine that uses 200 watts of power is moving objects a distance of 15 meters in 25 seconds. Find the force needed in the work done by this machine.
So as the question is being read, one of the first things I like to do is annotate the question for the variables present. That helps me recopy it into my problem-solving box much more smoothly, much easier. And I know that 200 watts is power. I know 15 meters is distance. I know 25 seconds is time. I'm looking for force. That's the unknown. And I'm looking for work. Okay, so it's going to take me a second to copy this all down. I'm looking for force. I'm looking for work. I'm given 200 watts, 15 and 25. 200 watts, 15 and 25. Just double check. That was 15 meters, 25 seconds. Okay, there we go. 15 meters, 25 seconds. Now, 200 watts would be the power. 15 meters would be the distance, and 25 seconds would be the time. Now, look at what you're trying to find here. I'm trying to find force, okay? And I'm given the power, I'm given the distance and time. Well, I have an equation that tells me power equals force times distance over time. And I can use that to solve for force. That's one that I could use. Then I'm trying to find work. Well, once I find the force, work is simply force times distance. Or power is equal to work over time. So I could use that equation to solve for work, or I could use that equation to solve for work, meaning you have choices. I hope you guys understand that, which means alternative solutions are valid. Okay, so let's go and split the solutions box in two, if you would, please. And for the first part, okay, I want to try and find, let me see. So based on this, I'm going to kind of work backwards. I'm going to do, just to make this really simple and quick, I have power and I have time, and I'm going to use that second equation, and I'm going to find work right off that. It'll just make it a lot faster. Work is power divided by time. How would I solve for work? How do I get rid of the time, guys? Multiply both sides by time. And so work is power times time. So it's 200 watts times 25 seconds. Okay, let's put that into our calculators together. 200 times 25 is 5,000 joules of work. Okay, so we kind of did the second part first, just to make it faster. And then finally, to find the force, I can just simply use work is force times distance and solve for F. And we've done that one already. You know, we divide by the D to get the F by itself. So force is work divided by distance. We're going to go 5,000 joules of work over a distance of 15 meters. And take the 5,000 that we had in the previous calculation, divide by 15, and we're looking at about 333 newtons of force, roughly. Okay, so something to note about this problem. I chose to do it this way, but what if I had chosen to work it originally with the equation I established? Well, force times distance divided by time. To get force by itself, I would have to multiply by time and divide by distance both sides, like that. Plugging into that equation, force is equal to power times time over distance, which is 200 times 25 over 15. And you can see 200 times 25 divided by 15 still gives you 333 newtons. So I just want you to see you have alternative ways of accomplishing the same thing. Again, ladies and gentlemen, don't forget to check out the supporting video in Google Classroom. If you feel like any of this part of the lesson went a little bit too fast, make sure you see it again.